Let's solve this question. The percentage of milk in three solutions S1, S2 and S3 are in geometric progression in that order. So it is given that there are three solutions S1, S2 and S3, and the percentage of milk in these three solutions are in the geometric progression in that order, right? If we mix, next is if we mix S1, S2 and S3 with their volumes in the ratio 2:3:4, we obtain a final solution containing 32% mix of milk. It is given that if we mix these three solutions in the ratio 2:3:4, then we get a solution containing 32% milk. However, if we mix S1, S2 and S3 with their volumes in the ratio 3:2:1, we obtain a solution containing 22% of the milk. Then we have to find what is the percentage of milk in the solution S1, right? So options are not there. We cannot assume any random number. It is given that percentages are in the geometric progression in these three solutions. So I'm letting these three percentages be S1, S2 and S3, right? If these are mixed in this ratio of 2:3:4, I'm getting a solution in which there is 32% milk, right? And it is given if I mix them in the ratio, this is first case, and in second case when these are mixed in the ratio 3:2:1, I am getting a solution having 22% milk, right? It is given, and the percentage of milk in these solutions are in GP. So let concentration of milk in these three solutions be, let percentage of milk in these solutions be in S1 I am assuming it to be A, in S2 I am assuming it to be AR, and S3 I am assuming it to be AR square. Why? Because these numbers are in GP. A is first term, R is the common ratio of this GP. So three terms would be A, AR and AR square, because it is given in this order, they are in GP, right? Now we have to use the concept of weighted average, and we should get two equations. By solving these two equations, we should be able to get the value of A and R, right? Simple. S1, S2, S3 are mixed in this ratio to get 32% of milk. So S1 contain A% of milk. So A% of the volume is 2 units. When mixed with AR% solution, AR% milk in the volume 3 units plus AR square percentage of 4 units are mixed to get what? 32% milk, right? It is divided by, this is weighted average, this is nothing but the weighted average, total volume being 2 plus 3 plus 4, and it is equal to 32% of the milk, right? Second equation being same, these three solutions, now only the ratio is changed, right? So A percentage of milk is mixed in this ratio now, AR percentage into 2 plus AR square into 1. So this is in the percentage upon 3 plus 2 plus 1 is equal to 22%, right? Now what I have to do, I have to get rid of one variable, right? I have to get rid of one variable, and I need these two equations to be one in one variable to get the value of that variable. So what I can do is I can take A common from this equation, I can take A common from this equation, and I have to divide these two equations, right? Naming them 1 and 2. So I'm writing directly that divide 1 by 2. Divide equation 1 by 2. What am I left with is, I'm cancelling all these percentage signs, right? So I'm writing it directly 2 plus this is 3r plus 4r square is equal to 32 into 9, and it is divided by 3 plus 2r plus it is r square, and it is equal to 22 into 6, and these equations are equation 2 is dividing equation 1. Now cancel out the terms 3, 2, 16, 8 and 11. Cross multiply these terms to get the value of r, or get that quadratic equation in r. So it becomes 44r square, 8 this is r square, and this is 44, this is 24 here, 44, so I get 20r square. Second, this is 33r and 24r, 48r, 33r. If 48 goes to this side, it becomes minus 15r. 11 into 2, 22, and 24 into 3 is 72. So 22, 72, minus 50 is there, is equal to 0. Cancel 5s. So 4r square minus 3r minus 10 is equal to 0. I can break 40 or minus 40 in two terms such that their sum is minus 3. So they are minus 8 plus 5, right? Product is minus 40 and sum is minus 3. So this equation can be factorized like 4 times r minus 8 by 4 and r plus 5 by 4 is equal to 0. And from here I get the value of r as 2 or minus 5 by 4, right? So I'm getting two values for common ratio. This is r. Now it is given that these three solutions are in geometric progression with the common ratio such as this. So I'm getting two values for the common ratio. One is 2 and one is minus 5 by 4. Now if I use this value r is equal to 2, I can find the value of a, right? I have to find the value of I have to find the value of this variable a, which is the percentage of milk in solution 1. So use r equal to 2 and put this value of r in equation 1 to get the value of a. I am writing it directly. R being 2, I get or you can just use this equation, right? This is the first equation. 2 plus 3r plus 4r square is equal to 32 into 9. So I am using this only. I get 2 plus, I have cancelled out a, right? So it becomes a times 2 plus 3 into r is 6, r square, that is 4 and 4, 16 and 6, 22 and 2, 24. So 24a is equal to 32 into 9. If I cancel these terms, 8 4 times, 8 3 times, we get cancelled 3 times, I get value of a as 12, right? So what is asked, what is the percentage of milk in solution S1? So the percentage of milk in solution 1, I have assumed this value to be a, and a coming out to be 12. So correct answer to this question would be 12%, right?